Today, I'll be presenting about what is digital signature in blockchain. Before getting into details, let's look at the overall understanding of digital signature. First, obviously it is digital, unlike the signature we usually use in restaurants using a pen and a paper. However, the main purpose of the signature remains the same in blockchain. Signature should prove that the transaction belongs to an individual and it should not be copied by anyone else. The key here is that the signature is unique. In real life, it might not be too hard to do so. But how do we achieve this in digital world? Here, instead of having a complicated signature, we'll use public and private keys in blockchain. Say there are two people called Alice and Bob. Alice wants to send a message to Bob. But Alice somehow can't see Bob face to face. So Alice passes the message to a third person called Charlie. And Charlie passes the message to Delta. And Delta passes it to someone else. And this process just keeps going on. And then finally, it arrives at Bob's place. What Alice is scared of is that these people in between Alice and Bob might change the content of the message. So Alice can just send a message like this. Here comes the digital signature to make Alice feel secured about sending message to Bob. Alice wants to send a message, "Hello Bob." First, she hashes this message and gets a unique value like many X's. Of course, the actual hash value is not gonna be like this, but I'm just using it to make this simple. After she got this value, she uses her private key to encrypt this value, and this will be her digital signature. After she got her digital signature, she's gonna pack everything into one. Her digital signature, public key, and the message. Now, she's gonna send it to Bob, and Bob gets everything too. Now Bob is gonna use Alice's public key to decrypt it and see what he gets. Bob will compare two values here, the hashed value of the message and decrypted value of the signature. If these two values agreed, say in this case both of them gave XXXXX, then the message has not been modified so that it is a valid transaction or message. However, problem comes in when these two values didn't match. Recall the feature of the hash function. If you give an input A, it will always return input B. Following this property of hash function, if you give the message into a hash function, then it should provide you an XXXXX output. And also the decryption of this digital signature should match with this XXXXX. However, in this case, it didn't match. But remember that digital signature was created by using Alice's private key, and Alice is the only person who has her private key. Which means that message is the one that got modified and not the digital signature. Because input to the hash function is no longer the original message, it provided you a different hashed value, which is YYYYY, not XXXX anymore. So in this case, Bob can be sure that the message has been modified by someone else. There is also another case where Bob can be sure that someone have modified the message or not, when Bob can't even use the public key to decrypt the digital signature. Remember that public key and private keys are pairs. If you use public key to encrypt, then the only thing that can decrypt this is private key. And also, if you use private key to encrypt something, and then public key the only thing that can decrypt. If Bob can't use Alice's public key to decrypt the signature, then the private key and public key doesn't match, indicating that someone else used different private key to create a fake digital signature. Therefore, this transaction or the message is no longer valid or reliable. By going through the process of comparing these two values, Bob can be sure whether the message has been modified by third parties or not. You might notice the weakness of digital signature here. Recall that the blockchain is semi-anonymous. There is no way for us to know who actually owns the public key. So even if we are certain that message is not modified, we still can't be sure that the message is actually created by Alice or not. One solution to this is to post your public key on Facebook profile or any social media. This way, Bob can just come to the Facebook page and check if the public key that Alice gave to him matches there or not. But there is a problem. 1. Bob needs to waste time there. 2. If Alice wants to make a transaction with different people, every single person have to come to Facebook page and compare the public key there. Honestly, this is not realistic. So there is another solution by using third party called Certification Authority. This Certification Authority gets a public key and ID from an individual and issues an electronic certificate. This certificate basically proves that there is a relationship between public key and an individual. So instead of Bob coming to Facebook page or anyone coming to Facebook page, Alice could just send electronic certificate to them. Certification Authority is very useful. But if you think about this, the existence of Certification Authority is actually going against the purpose of blockchain, which is decentralization. A lot of people are arguing about this, but I personally think it's fine to have Certification Authority. The reason is simple. Blockchain is just a tool to solve a problem in the world. It's not always have to be decentralized for me. If it is better to have a decentralization or transparency in something, then blockchain is definitely the way. We should use blockchain there. But if forcibly using blockchain makes the system inefficient, we should not be using blockchain there and just have a central figure to make it work better. Again, this is controversial, but this is my personal opinion. So here is a summary of what we have learned today. I think the topic today was pretty heavy and probably more technical than what we have learned so far. If you didn't understand the topic well, please pause the video and read through the summary, or go back and watch the video from the beginning one more time. Thank you for watching.